The Institute for Accessible Science, or IAS, began in 2010, established through the NIH Director's Pathfinder Award. And the purpose of the Institute for Accessible Science is to target and break down those physical and attitudinal barriers that prevent people from disabilities from succeeding in the sciences. Particularly, we're looking at students as they progress through higher education. Our long-term goal is really to promote their independence and also be able to participate in more of the practical or hands-on learning experiences.
A $2 million grant in 2010, administered by the National Institute of General Medical Sciences and funded by the American Recovery and Reinvestment Act, has allowed Purdue to create a new biomedical sciences lab that is accessible to those with physical challenges.
Most laboratories are designed for people who stand. The idea is to design them in such a way that they would accommodate people who would be sitting down, or in this case, in wheelchairs. Brad Duerstock is really the engine behind all of the things that have happened related to looking at people with disabilities and finding accommodations for those people with disabilities.
I'd like to welcome you to the physical space of the Accessible Biomedical Immersion Laboratory, or ABLE, here at Purdue University in the Hall of Discovery Learning Research. The first is the lab workbench, and this lab workbench is similar to the others, except it is adjustable height, so it can accommodate wheelchair users, people who use stools, or if they're standing. The other station is the fume hood. Again, this is a typical fume hood, but as you can see, compared to your traditional one, there is room underneath. There are switches are lowered, and the knobs are different in that they are more accessible for someone with limited grip. Compared to your traditional sink, we have open areas underneath, a shallow sink. The faucet is forward, so it can be reached. We also have braille labels so that someone, even from a wheelchair, can do a lot of the same lab activities as that someone without a disability. This is a typical emergency safety shower and eye wash basin. And what we've done here is we modified it so that one in a wheelchair can reach the pole for the emergency shower. As you can see, the original one is very high. And we also added a lot more signage so that someone with even visual impairments can be directed to this in case of emergency. These are some of the simple modifications that can be made to make a lab environment more safe for everyone, including those with disabilities.
And then from there, we modeled all that information in terms of being able to put it into a computer. Our vision is to put all this online so that someone can actually take this information as a blueprint, if you will, a 3D blueprint, and be able to download it and design a facility that would accommodate those with lower limb disabilities.
We would reconstruct the entire environment inside of a three-dimensional setting and then port that into our engine that we're using for running this simulation.
This 3D virtual model of Purdue's real-life biomedical immersion lab allows non-disabled users to simulate lab tasks from the perspective of someone in a wheelchair.
So if you are in the wheelchair mode, we are basically allowing the user to reach a certain distance based on, let's say, an average of, if they're 5 feet 10, then this would be their average arm length. So if we have a piece of equipment, or like for example the safety shower, if it requires you to extend your hand and pull down on the shower to activate it, we want to try to get as close as we can to that same type of interaction. And by just using very simple calculations, you can really predict what your capabilities are and illustrate that when you're interacting with the hardware.
And another feature that we're really looking at is safety. If something catches on fire or a chemical spill, and how does someone get to the safety equipment such as the emergency shower and the emergency eye wash. And it's really noticeable when you think about someone with a visual impairment.
We actually had the pleasure of meeting one of Brad's students where her field of view is limited to a very narrow angle. And in the process of her trying to explain how she works with an environment, we tried to create, as close as we can, how that would actually feel by limiting the field of view.
Being able to provide it online, they provide so many ways of accessing these visualizations through a web browser, to be able to use stereoscopic glasses to get that 3D effect. And then if we add certain tasks that they need to perform through a simulation, they can actually practice these tasks.
We've incorporated the Americans with Disabilities Act components with that as well. And with a touch of a button, you can say, design this facility because we know it works.
You're giving somebody that experience without having to actually be there. So it's like when people say, put you in somebody else's shoes, we're actually doing that.
Going to the next level and being able to model this and to offer it online for anybody who wants to use it, I call that lightning in a bottle, because once you've captured that and the world, you say, we're giving it to the world. And that to me is the exciting part of this whole story, is that I believe that we've got lightning in a bottle right here. We want other people to know about it and we want to share it.